So in this video, we'll be looking at upper and lower bounds and also focusing on error bounds. Now, when a number has been rounded by a certain degree, so for example, when a number's been rounded to the nearest whole unit, or 10, or 100, or 1,000, or million even, or rounded to decimal places or significant figures, then there are a range of values that the number can actually be. So for example, if you take the number 45 and we know that it's been rounded to the nearest whole number, then that number can actually be any number between 44.5 and 45.5. Now, so looking at the scale, what we can then assume that our lower bound is basically the smallest that the actual number could be. The upper bound is the biggest number that it can be. Now, before we move on from that, a lot of students tend to think, well, this hang on a second, 45.5 would actually be rounded to 46, which is actually true. Now, technically, you're looking at 45.49 recurring, but the problem is the fact that yes, that would be true. That is going to be the biggest number that it can be, because as soon as it turns into a 5, you think about rounding, that you look at the number next to it. If it's a number bigger than 4, you increase it by 1, and that would actually be true. However, if you actually convert this into a fraction, then what this would then become is 45 and a half. Now, if you're not too sure about how to convert recurring decimals into fractions, then again, you can watch a video which I have produced that allows you to do that. So this is one of the reasons why we write 45.5 as our upper bound. So yes, you might think, well, this surely is your upper bound, but if you want to get full marks in your exam, I would strongly recommend that you write it as 45.5. Now, when it starts talking about the error bound, now this you need to write as an inequality. And this will always take this format. So here you're always going to have your upper bound, your lower bound first. So this number here is your lower bound. This inequality will always be less or equal to, or should I say, it should be more, yeah, less or equal to. And then you've got any letter, so this could be absolutely any letter. So if you want to pick X or N, it doesn't really matter what the letter is, as long as there's something in the middle. And this value here will always be your upper bound. Now, the key thing to also note in this is that this has to be a less than, always less than. Because as I mentioned, that if you were to have 45.5, then that actually would be rounded up to 46. So this inequality of, I shouldn't really be underlining it, but this inequality here means that the number has to be less than 45.5, thus allowing it to be rounded down to whatever number that you're working with. So let's have a look at the method of finding the upper and lower bound. Now, generally speaking, you probably do this mentally. You can kind of just look at a number, look at what it's been rounded to, and then automatically write down the lower and upper bound. And these questions are usually worth 1 mark. So it's either going to be right or wrong. There's no really formal working out that's needed. However, for some questions, it can be a little bit more complicated, which hopefully by using these methods, it will hopefully make a bit more sense. So the method to find the lower and upper bound and the error bound can be done by following the following steps. So the first step is to divide the rounding measure by 2. Now, if you're given the, let's say a number is rounded to decimal places or significant figures, then the actual place value is going to change for every question. So, and again, when we go through some examples, I will explain what to do in those situations, but you tend to find that at a lower level, they'll say, the number's been rounded to the nearest 10, or actually give you worded rounding, whereas at high level it is going to give you in terms of decimal place or significant figures, in which the placing of that digit or the place value is going to change. Now, for the lower bound, what you need to do is subtract the answer in step 1 from the original number, and to get for the upper bound you add it to the original number, and then for the error bound, again, you just write it in that format of the inequality that we've just previously discussed. Now, I would strongly recommend you make a note of the steps that are on there, and like I said, if they make absolutely 0 sense to you, do not worry. When we go through some examples, I will sort of call back in it and try and give you more of a clearer explanation about what each of these 4 steps actually mean. So let's have a look at some very commonly asked questions relating to this particular topic that you may get asked in either your classwork, homework, or in an exam. So number 1 says the length of a desk is 150 centimeters to the nearest 10 centimeters. Find the upper and lower bounds. So it's kind of been guessed to nearest 10 centimeters, and it's been rounded. Now, generally speaking, if you think of a scale and you're going up in 10 centimeters, now this is just another way of doing it. So I've got 140, I'm going to have 150, and I've got 160. Now you're looking for the regions of where this desk could be written. So it's going to be halfway in between these two. So here it's going to be 145, 155, and any length between this region here is going to be rounded up to give you 150 centimeters. So the lower bound is 145 and the upper bound is going to be 155. Now, in terms of the steps of what we talked about, let me just explain to you how that all works. Is we look at the rounding. So this has been rounded to 10 centimeters. So if I just look at question 1, it's been rounded to 10 centimeters. Now, if I divide that by 2, I get 5 centimeters. And then what I need to do for the lower bound, what I need to do is look at the original number, which is 150, and I'm going to take away 5 centimeters, which gives me 145 centimeters. For the upper bound, I get the original number, which was 150. I get the answer from my dividing by 2, which is 5, and I add that, so that's going to give me 155 centimeters, and there are my upper and lower bounds. For question 2, it says that a man weighs 86 kilograms to the nearest kilogram. State the error bound. Now here, my rounding is to 1 kilogram. So if I do 1 kilogram divided by 2, that's going to give me 0.5 kilograms. So to find my lower bound, what I need to do is take it away from the original number, which was 86. So 86 minus 0.5 is going to be 85.5. And my upper bound is going to be 86 plus 0.5, which is 86.5. So looking at my error bound, now if you were to be able to get these numbers straight from the head by reading the question, brilliant, well done. Like I said, you don't need to show any working out. If you're just writing down the actual answer, then that's going to be fine. But just make sure that you are labeling which one is your lower, which one's your upper. And so here the error bound is going to be equal to 85.5 is less or equal to, now because we're dealing with weight, I'm just going to call it W, but again you call it anything, any letter you want, and then my upper bound is 86.5, and there is my final answer. Now when it comes to question 3, so question 3 says 15,600 has been rounded to 3 significant figures. Find the upper and lower bound. Now here my third sig fig is the 6, and that 6 represents hundreds. So if I then do 100 divided by 2, then that equals 50. So what I need to do is add and subtract 50 to 15,600. So here my lower bound is going to be the original number, which was 15,600. Take away 50, which gives me an answer of 155, and it's going to be 50. And then my upper bound is going to be 15,600 plus 50, which is 16,000. So 15,000 rather. I'll put a 6 there. 650, and there is my upper and lower bound. Now moving on to question 4. So let's just get rid of all of this. And there is a much quicker way of me cleaning this up, but it's probably more therapeutic. Right, so moving on to question 4. It says that 54.8 has been rounded to 1 decimal place. Now 1 decimal place is the 8, and that represents the 10th. Now a tenth is 0.1, so if I do 0.1 divided by 2, then that's going to give me 0.05. So then what I then need to do is, so for my lower bound, it's going to be the original number, which was 54.8, and I'm going to take away 0.05. which then gives me an answer of 54.75. And the upper bound is going to be 54.8 plus 0.05, which gives me an answer of 54.85. So here my error bound is going to be 54.75 is less or equal to, let's go for n because it represents number, and I've got my upper value, which was 54.85, and there is my final answer. Then moving on to, and again to create a bit of space, and let's just be, which I should have done about 5 minutes ago. So here, moving on to question 5, I've got 14.6 centimeters has been rounded to the nearest millimeter. Now the nearest millimeter is this 6, that's my millimeter measurement. So here, if I look at my nearest millimeter, I've got 0.1, which is what 1 millimeter is. I divide that by 2 and I get 0.05. So what I then need to do is, again, to find the minimum and maximum length. So the minimum length is going to be, which is basically the lower bound, is going to be 14.6 minus 0.05, which gives me 14.55. And my maximum value is going to be the original number, which is 14.6 plus 0.05, and that's going to give me an answer of 14. Oh, I keep writing 15. So I've got 14.65, and there is my max and minimum length. And again, just need to add the units, which is really important that you don't forget. So moving on to completing this table. Now, if you want to have a go at these questions, feel free to pause the video and then have a go at your own attempt. And then, like I said, what I'm going to do now is go through the potential answers. So the first thing I want to do here is looking at this. This is what the numbers have been rounded up to. So for this, what I'm going to do is I'm just going to divide each of these numbers by 2. So here I've got 2.5. And again, let me just... So there. And then this one's going to be 0.05. This is going to be 5. This is going to be 50. Now to one decimal place, that's going to be 0.05. And to 3 significant figures, that represents tens. So then that's going to be a 5. Now these are the numbers that I'm going to be adding and subtracting to get my lower and upper bound. So for this, what we need to do is minus, and this we need to add. So looking at this, we've got 5, and let's go for pink. So here we've got 5 minus 2.5, which is going to be 7.5, or it should be 10, not 5 rather. So we've got 10 minus 2, which is 7.5. I'm going to have 10 plus 2.5, which is 12.5. And again, don't forget the units. So my error bound is going to be 7.5 n and 12.5. And again, make sure the inequalities are the same. So that first one should be less or equal to, the last one should be just less than. And your inequality should always be pointing in the left direction, never to the right, or in opposite directions. So moving on to the second one. So let's actually just label these so you know what I'm talking about. So moving on to question 2, it's going to be 12.5 minus 0.05, which equals 12.45 centimeters. This one I'm going to do 12.5 plus 0.05, which is going to give me 12.55 centimeters. And the error bound is going to be 12.45 less or equal to n, which is less than 12.55. And again, stick in centimeters in the units. Would you lose marks if you didn't write the units? I don't know, it depends. In an exam, maybe. I think it'd be pretty harsh, but generally speaking, it's always good practice and something that you should always do, just like writing a full stop at the end of a sentence. So moving on to question 3, again, I'm going to add and subtract 5. So I've got 120 minus 5, which is 115. And here I've got 120 plus 5, which is 125. So my error bound is going to be 115 meters, less or equal to, call it L, and 125 meters. Moving on to question 4. Again, I'm going to add and subtract 50. So here what I've got is 1200 minus 50, which is 1150 kg. Then I'm going to have 1200 plus 50, which is 1250 kg, and the error bound is going to be 1150 kg less or equal to, let's call it W, and it's going to be 1250 kg. And then moving on to question 5, again I'm going to add and subtract 0.05. Let's go for orange. So I've got 34.5 minus 0.05, which equals 34.45. And then I'm going to have 34.5 plus 0.05, which equals 34.55. So my error bound is going to be 3445. And I don't know what we're measuring, so let's call it N. And we've got 34.55. And then finally with question 6, let's go for green. So here I'm just going to add and subtract 5. So again, the third sig fig represents tens. So it's just going to be plus or minus 5. So I've got 2580 minus 5 equals 2575. I've got 2580 plus 5, which is 2585, giving me 2575 less or equal to X. Again, any letter is absolutely fine. And 2585. And there you go. Now, typically speaking, if this was an exam, what they would usually do is do this, excluding a little dot. Let's just get rid of it. And all you'd have to do is just write in your upper and lower bound. So again, re-emphasize, the letter doesn't make a difference, but you definitely need something in the middle between the two upper and lower bounds. So let's have a look at a worded problem or problem solving questions that again seem very, very popular when it comes to exams or testing of this particular topic. So in the first question it says the lengths of the rectangle have been rounded to 1 decimal place. And question A says find the minimum maximum perimeter, and B says find the minimum maximum area. So first things first, what we need to do is we work out the minimum, the two lengths that each of the lengths could be. So the minimum that this could be, because it's been rounded to 1 decimal place, so 1 decimal place looks like this, divide that by 2 and we get 0.05. So what I need to do is do 20.6 minus 0.05, which equals 20.55. That's the smallest. Then 20.6 plus 0.05, and that equals 20.65, and that's going to be the maximum length. Then moving on to the height of the rectangle, well again I'm going to add and subtract 0.05, so it's going to be 7.2 minus 0.05, which is 7.15, and that's going to be the min. Then I've got 7.2 plus 0.05, which is 7.25, which is the maximum. Now to find the minimum perimeter, what I need to do is use the smallest lengths. So the smallest lengths are 20.55 and 7.15. So here I'm going to do 20.55 plus 7.15 plus 20.55 plus 7.15. And again, if I plug that straight into my calculator, which I'm now going to do, alternatively you can just times the two different lengths by 2. So it's entirely up to you how you go about working this out. And we get an answer of 55.4 centimeters. Again, don't forget the units, and that's the minimum perimeter. Now for the maximum perimeter, what I need to do is use the maximum values that it could be. So it's going to be 20.65 plus 7.25 plus 20.65 plus 7.25. So again, working that all out on my calculator, or again, if it was to be worth a few more marks, it might be on the non-calculator paper. I get an answer of 55.8 centimeters, and that is the maximum perimeter. like so. So moving on to B, which I'll do this in different colours, so B. So in terms of the max area, well, let's go for minimum first, to keep it consistent. So the minimum area is going to use the minimum lengths. So it's going to be, the minimum length is 20.55 times the minimum height, which was 7.15. And again, if I type that into my calculator, I get an answer of 146.9325, and it's going to be centimetre squared. Now for the maximum area, I need to use the longest length that it could be, and that's going to be 20.65 times 7.25. And again, if I type that into my calculator, I get an answer of 149.7125 centimetre squared, and there are my two answers. Now, typically speaking, in an exam, you probably get asked to work out one. It might ask you for the error bound, in which we just need to write it in inequality like we've done previously. But again, make sure you are reading the questions carefully. Don't just automatically see a question and think, right, I know what to do. And like I said, practice of rounding to 1 decimal place, 2 decimal places, 3 decimal places. It's all about what does that number actually represent. And again, these questions are classed as a higher level, only because it requires a lot more understanding about what it is. So let's have a look at some calculations that you may need to do. Now, for more high level questions, a question might give you a link between algebraic substitution. Now, this is something that you may want to make some general notes on when revising this particular topic. Now, if you are working with error bounds and you've got two values that are either being added together, subtracted together, multiplied together, or dividing together, then to find the minimum and maximum values, it's not necessarily using the lower values for the minimum or the highest values for the maximum. You kind of need to have an understanding of actual maths calculations. So when you're adding, to get the lowest number, you just got to add the two lowest numbers together. To get the maximum number, you just need to add the two possible maximum numbers together. For subtraction, to get the lowest number, you need the first number to be as low as possible, but the number that you're going to be taking away needs to be as big as possible. Now for the maximum value, you want the first number, the original number, to be as big as possible, and you want to be taking away the smallest number possible. Now for multiplying, it doesn't really make a difference. A bit like adding and subtracting, the order doesn't make a difference. So if you want the smallest number and you're multiplying, just multiply the two smallest versions together. If you want the highest number, you just multiply the two upper values together. Now dividing works in a very similar way to subtraction. The order doesn't matter. So to get the smallest possible answer, you want the smallest numerator with the biggest denominator, because you want it to be dividing by more parts and sharing less. For the maximum value, when you're dividing, you want the highest possible denominator and the lowest possible denominator. Now again, if that makes absolutely no sense, let's quickly put it in terms of a question. So looking at this particular question, it says that if A equals 5.6 and it's been rounded to 1 decimal place, and B is 4,200 and that's been rounded up to 3 significant places, or significant figures I should say, then state the maximum and minimum values of A plus B. So looking at A, and let's find a pen that works. So here we've got A. So the minimum value that A could be, well, it's been rounded to 1 decimal place, that's 0.1. So divide that by 2 gives me 0.05. So the minimum value is going to be where I plus and add 0.05. So the minimum value for A is going to be 5.55. Now the maximum value that A is going to be is plus 0.05, so it's going to be 5.65. Now for B, this has been rounded to 3 significant figures. Now the third significant figure represents tens, so if I do 10 divided by 2, that equals 5. So what I need to do is add and subtract 5 to this particular number. So the minimum number that B could be is going to be 4195, and the biggest number it's going to be is 4205. And again, all I've done is added and subtracted 5 to our original number. Now it's these numbers that I'm going to be using to work out what the maximum and minimum values of these are going to be. And again, what I'm going to be doing is I'm going to be using this table to help me to find out what the minimum and maximum value is going to be. So for adding, to work out the minimum value, what I need to do is use the smallest numbers of each of those letters. So it's going to be the smallest a, which is 5.55, plus the smallest b, which is 4195. And all I'm going to do, I'm going to type that into my calculator. So I've got 5.55 plus 4195 gives me an answer of 4200.55. Now the maximum value it's going to be is where I use the, when I'm adding, I use the two biggest numbers. So it's going to be 5.65 plus 4205. And again, I type that into my calculator and I get an answer of 4210.65. Now, when working with subtraction, so again, to get the smallest value, I want to use, if I go back, to get the smallest value, I need the smallest first number and the biggest second number. So to get the smallest value here, I need to use the smallest a, which is 5.55, and I'm going to subtract the biggest b value, which is 4205. And again, if I type that into my calculator, I'm expecting a negative number, which I get, and that is minus 4199.45. Now to get the maximum value this is going to be, then I'm going to use the biggest, again to go back, I'm going to use the biggest first value, which is 5.65, and I'm going to subtract the smallest b value, which is 4195. So here I do that calculation, so 5.65 minus 4195, which gives me an answer of minus 4189.35. Now, although they are negative, that maximum value is still bigger because it's less of a digit than the first one, so therefore that is going to be correct. Now, when we're multiplying, again, when we're multiplying, to get the smallest value, I just multiply the two lowest numbers together. When I get the maximum values, I just need to multiply the two biggest numbers together. So let's just sort the screen out. So there we go. So the maximum value, or the minimum value I should say, I'm going to get is using the smallest a value, which is 5.55, and multiply that by the smallest b value, which is 4195. And again, type that into my calculator. I get an answer of 23,282.25. Now to get the maximum number, I need to multiply the biggest a value, which is 5.65, and the biggest b value, which is 4205. So again, typing that into my calculator, I get a value of 23758.25. And there we go. And then now finally for our b value, now to get the smallest value when you're dividing, I need the smallest a value divided by the biggest b value. So here I've got the smallest a value, which is 5.55. I'm going to divide that by the biggest b value, which is 4205. So again, I'm going to do 5.55 on the calculator divided by 4205. It's going to give me not so nice number, which it hasn't, which is going to be 0.00131957,313. Or if you're looking at a calculator, it might be 1.319 blah 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 times 10 to the power of minus 3 if your answer is given in standard form. Now for the maximum value, to get the biggest one, I need to use the biggest a value, which is 5.65, and divide that by the smallest b value, which is 4195. So again, I'm going to reach for my calculator, do that division, and I get an answer of 0.00134684148, or you'd get 1.346 blah 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 times 10 to the power of minus 3. Again, if they were given as fractions, which my calculator has done, just press the SD button and that will standardize it if you are using a Casio calculator. So hopefully that gives you an insight into upper and lower bounds. And again, for these questions, if I wanted to work out the error bounds, then all I need to do for the error bound would be to do the lower bound is less or equal to x or n or whatever, and is less than the upper bound. And there I'd have my error bound for each of these. And apologies for using brown pen and it not coming up clearly on the screen, but hopefully that makes sense. So I will put a few worksheets in the description below with their answers for you to practice everything you've learned in this video, and also to test your understanding of it as well.